Hi, this is Algorithm Syllabus. In Chapter 1, I discussed algorithm analysis that comes under asymptotic worst case time and space complexity. In Chapter 2, I discussed brute force technique. There I discussed sequential sorts that comes under sorting, selection sort, vowel sort, and radix sort that comes under sorting. And I discussed depth first search and breadth first search that comes under graph traversal. In chapter 3, that is a decrease and concur technique, I discussed insertion sort and topological sort that comes under sorting, binary search that comes under searching, topological sort that also part of graph traversal. In chapter 4, I will discuss divide and conquer technique. There I will discuss min-max problem, matrix multiplication, merge sort, quick sort, binary tree traversal and related properties. So min-max problem, matrix multiplication comes under divide and conquer technique. So min-max problem, matrix multiplication comes under divide and conquer technique. Merge sort, quick sort that comes under sorting, also divide and conquer technique. And binary tree traversal and related property that comes under divide and conquer technique. Let's discuss chapter 4, divide and conquer technique. In chapter 4, first I'll discuss introduction of divide and conquer. Then I'll discuss min-max problem, matrix multiplication, merge sort, quick sort, binary tree traversal and related properties. Let's start divide and conquer. So what we are doing, some problem is given, some instance is given, that will divide into sub problem, then we'll try to solve individual sub problem, then we'll combine the solution. So you can say divide and conquer algorithm work according to following general plan. First divide, then conquer, then combine. So first is divide the problem into number of sub-problem that are smaller instance of the same problem. Suppose one problem is given of 10 element, then that we can divide into 5 and 5. Next, conclude the solve problem by solving them recursively. So we'll try to solve this problem recursively. If solve problem size are small enough, however, just solve the solve problem in a straightforward manner. Suppose 5 element, we can solve recursively. Suppose there is just one element, then we can solve directly, straightforward. Next step is combine. Combine the solutions to the solved problem into solution for the original problem. So first we'll divide the problem into solved problem. Then second we'll conclude the solved problem, means we'll try to solve the solved problem recursively. If it is too small, then we can solve directly. Next we'll combine the solution and we'll get solution for the original problem. So divide and conquer recurrence relation are in this format. Tn equals to at n divide b plus f of n. I already discussed how to solve this type of recurrence relation. We can use back substitution method, or we can use the recurrence tree method, or we can use the Master Theorem. I also discussed recurrence relation for decrease and conquer. In case of decrease and conquer, recurrence relation is T of n equals to a t n minus b plus f of n. Here just mark, here n minus b, here is n divide b. N minus b means we are decreasing n by b. Here we are dividing n by b. When the subproblem is large enough, we can solve it recursively, called as recursive case. If the subproblem is small enough, then we call it as base case. Suppose t of 1 equals to 0. That is our base case. Next, diagram of the divide and conquer. So one problem of size n is given, that we can divide into subproblem of size n divide 2. You can also do n divide 3, n divide 3, n divide 3. It's depend on problem. We can divide by 2, we can divide by 3, we can divide by any number. Next, we'll find solution to solve problem 1, we'll find solution to solve problem 2. Finally, we'll find solution to original problem. We'll combine these two solutions and we'll find solution to original problem. So this is the strategy for divide and conquer. We are dividing problem into solve problem. We are trying to solve the solve problem. Then we'll combine the solution. I already discussed Master Theorem for divide and conquer recurrence. This is just a revision. If one recurrence is in this format, t of n equals to at n divide b plus f of n, then we will find n power log a base b, and that will compare with f of n. If f of n is less than this, then it comes under case 1. Running time will be theta of n power log a base b. If f of n equals to n power log a base b, then that comes under case 2, that is theta of n power log a base b multiplication log n. If f of n is greater than n power log a base b, that comes under case 3. Again, we need to check a f n divide b should be less than equals to c multiplication f of n. Then t of n, then running time will be theta of f of n. This is the Master Theorem according to Corman book. I also discussed one modified Master Theorem. Case 1 and case 3 are same, just case 2 little bit modification. So with comparing n power log a base b, we'll also add this log n power k. If no log is given, just consider k equals to 0 if no log is given. Then if k value is greater than -1, if it is 0, if it is 1, 2, 3, any value, then running time will be n power log a base b multiplication log n power k plus 1. Suppose no log is given means k value is 0, then we'll multiply log 0 plus 1. 0 plus 1 means 1, so we'll just multiply simply with log n. Suppose no log is given, it is same as case 2 of Corman. If some log value is given, means if k equals to -1, then running time will be theta of n power log a base b multiplication log of log n. If k less than -1, then running time will be theta of n power log a base b. So it depends whether any log value is there or not. Accordingly, we can use. If no log is given, simply use case 2 of Corman. You can use any master theorem for divide and conquer, whether Corman or modified version of Corman master theorem. I already discussed detail in first chapter, that is algorithm analysis. How to solve divide and conquer recurrence relation. We can use back substitution, recurrence tree method, also master theorem. These are some examples of recurrence relation. Tn equals to 2t n divide 2 plus 1. Tn equals to 2t n divide 2 plus n log n. Next, Tn equals to t 2n divide 3 plus 1. Tn equals to t n divide 3 plus n. You can solve this recurrence relation in three ways. You can either apply back substitution method or recurrence tree method or master method. For master method, you need to identify what is value of a, what is value of b, and what is f of n. Then we'll find n power log a base b, and that will compare with f of n. You can use any of the master theorem if there is no log in f of n. I already discussed detail in first chapter. Just go through first chapter, you can easily understand. And this much is enough for divide and conquer introduction. In next lecture, I will start min-max problem, and if this lecture is helpful for you, please like and subscribe. Thank you.